name is Mark Merritt. All right, I am your professor for this course. This is DBAS 2798. All right, so just to go over the announcements here. So I'm not here right now, guys. I'm actually out the country this week. I know we missed the first lecture on Monday because there was a holiday. So this lecture will pretty much just be a catch up for both sections. All right, so you can just watch this video. You can reach out to me. So I actually am on Discord most of the time. Join the Discord channel. You can talk to me. All right, my email is markanthony.merritt@sheridancollege.ca. Now I'm not usually answering my emails. I do answer Discord a lot more. All right, but yeah. So I believe both classes will be at Davis campus. Right. So let's go to content here. Let's begin. So let's begin with the course outline. Right. So now the main professor for this course is Amandeep Kaur. All right. So she made this course outline for us, and she built the actual course material for us. And I am just pretty much going to be relaying that to you guys this semester. Pretty much this is a breakdown each week for the course. Right, so week 1, we will have an introduction. This will be this lecture, right? The use of DBs in software applications, software installation and configuration, and architectural overview. Right. So I'll just go over that in this section, in this lecture, and then next week we'll just talk about this again. And then next week we can probably go into this stuff as well. We can begin with this as well. Right, so the week after that, in the weeks coming, we'll have lectures each week, right? You will have assignments and projects. Let's go to the breakdown first. So there are going to be 5 assignments in the course, each worth 6%, so in total 30%. There'll be a case study worth 20%, which is a final group project, a midterm exam worth 25%, a final exam worth 25%. So there will be a midterm and a final. You will have an assignment, so there will be 5 assignments and a case study. Now there won't be any labs, right? There'll be no labs. It will just be pretty much us doing lectures every class, and then you'll get the odd assignment every now and then. At the end, you will have the project, which is a case study. You guys will do that in a group. So the group can be like maybe like 3 people maximum. There'll be a midterm in week 7 and a final in the last week. And you'll present the project as well to the class in the last week. Okay. So I hope that's straightforward for you guys. Now you need to get now you need, for me, just to pass the course with a 50%. That has always been my rule. In this course, it says students will attain both at least a 50% on 2 exams combined, and at least 50% in the final course in order to obtain a passing grade. So you need to make sure you. I'm gonna go by her rules that she came up with, because like I said, she built this course. So she's saying 50% on the 2 exams, and at least a 50% on the final overall mark. Core channel, right, over here. Right. As I will be uploading information about the course, posting announcements, like for example this week I couldn't make it, right? So I posted an announcement letting you guys know ahead of time. Also, I'll post things like labs. Well, not this class. There's no lab in this class, but assignments. I'll post announcements about that, and your tests, and I also will post code as well. Make sure you have Discord. Like I said, I am on here all the time if you need me. I hardly use my email. Slide, this one right here, under week 1. All right, so it says here, database design and implementation. So So DBAS 27198. Right. So this was the instructor who created this slide, right? Walid Bilal. Right. Now it says here, in this class we're going to define basic terms in SQL, recognize the history of databases in SQL, explain the advantages of databases, so why we use databases, list components of database environment, identify categories of database applications, describe database system development lifecycle, and then what is a database? So allows data in. So we can put data into a database. Like you see here, this funnel, I can sprinkle information into a database, right? And then have that data get used inside of a program. So structures and relates logically related data and or objects, allows information out. So here we put some information and it spit out John is a third-year semester student at Davis campus. Click on the link to see his photo. Okay. So data can come in different formats from different sources. Right? Data refers to factual information, and single data element is a single fact. Right? Data can be structured and non-structured. So data can not be structured and organized if there is no context to it. What is 3? Metadata describes the properties of the data and hence provides the information based on which it can be organized and retrieved. Okay. So data has to be processed in a way that increases the knowledge of the audience to become information. Data and metadata are paired to compose information. Data element can be combined to provide information. So a database is organized a collection of logically related data. Right? Data is stored representations of meaningful objects and events. So that this book that he refers us to, Hoffer A 2003, it is by Jeffrey A. Hoffer. All right. It is called Modern Database Management. So you guys should try to find it. I actually have a copy, so I will upload this copy, guys, to Slate. All right, it's actually here. So this book will help you in the course. All right, a lot of the slides are coming from this book. So it is a textbook. This edition I have, it's the 12 edition. So I can just upload this on Slate for you guys. Uploaded the book to Slate, so you can go ahead and download that. All right, so let's get back into it. So here we see more definitions. So information, data processed to increase knowledge in persons and data, and metadata is data that describes the properties and context of user data. So guys, these are definitions from the book. You can probably find it in the book's glossary. All right, so options to store data. Computer file processing systems. Proprietary tools, programs that store data in, manipulate, and retrieve large files. Databases management systems. Central repository of related shared data. Data is managed by a controlling agent, stored in a standardized, convenient form. So computer file processing systems. So here we have an order filing system, right? Program A, Program B, and Program C are all getting information from the database, right? So this is a system that's actually retrieving information from a back order file, inventory master file, and a customer mastery file. So these are databases that are being used to pretty much empower these programs and have them working properly and getting data back from a database, right? This one, accounting department, is taking an invoicing system and pulling information from a customer master file and inventory master file, right? So different systems are out there, guys, and they pull information from a database. This one, payroll department, is pulling information from the employee master file. This is like, pretty much in a nutshell, how databases work with our computer programs. So program data dependence. All programs maintain metadata for each file they use. Duplication of data. Different systems/programs have separate copies of the same data. Limited data sharing. No centralized control of data. Right? So more disadvantages here. Lengthy development times. The programmers must design their own file formats. Excessive program maintenance. 80% of information systems budget. Right, so there are some things, guys, that are a disadvantage of not having a centralized database, and these are them. Right, the first one is that all programs, right, will have to pretty much use different data instead of using the same one. Right? Instead of having a centralized database, like on the cloud somewhere, we're just using copies of data. Right? Right. So we want to have a centralized database that contains everything. Right? And we don't have to copy things over more than once, have duplicates. That's not good. Right? So a management system is a software system that is used to create, maintain, and provide controlled access to these databases. So here we have the management system, and it pulls all the information from a central database. Contains employee, order, inventory, pricing, and customer data. Right? So these systems have a centralized database instead of like this one here. This is just a file processing system. So pretty much the difference is that we're not having a centralized database. This is how databases work, like this, but it's not centralized, right? So using an actual central database and a DBMS, this will allow us to keep all of our information in the same place. It's a lot better. Databases is that they're program data independence, right? Plan data redundancy, improve data consistency, improve data sharing, and increase application development productivity. So guys, the main thing about databases is that we have independent data, right? So the data is by itself, right? It doesn't need multiple copies of each other. They're all centralized in one place. So that's a great thing about having a database. Right? Also, we have enforcements of standards, right? Improved data quality, improved data accessibility and responsiveness, reduce program maintenance, and improve decision support. So guys, databases are the way to go when using data inside of a program. So in a database environment, we have different components, right? We have a database, right, that's being managed by a DBMS system, right? And then we also have a repository, like GitHub, for example, that we're pretty much going to be uploading and retrieving things from for our actual program. So this is not like the actual data in the program. It's just retrieving updates about the actual program in the cloud. Like for example, UI changes or design changes I can pull from the cloud. Okay. Now this is the actual application that we use on this level. Okay. So we're getting back user interface from the repository, and we're getting back data from the database management system. Right? Here we have tools. We also have programs that make up our entire workspace. Okay. Then on our client side, the actual computer, right? This information goes to end users, to developers, and to database admin. Right? So there's a lot of different pieces inside a database environment. So evolution of the database system. We'll go back into some history here. Databases started to emerge in a file processing dominated environment. Database systems were mainly used for large projects like the Apollo Moon landing project. In the late 1960s, Database Task Group was established as the first effort for database standardization. In the 70s, databases entered the mainstream and became commercial reality. Hierarchical and network databases were developed to be able to store data about complex processes like manufacturing bills of material. E.F. Codd and others developed the relational model. So guys, databases came around around the 60s, right? And were very popular once they came out because this was a new way of storing data in a program. Right, so in the 80s, the commercial spread of relational data model. Relational models store data in tables and use SQL to manipulate the data. Relational model was well suited for client-server computing, parallel processing, and graphical user interface. All object-oriented databases were introduced to accommodate the storage of non-structured data types. Relational databases are the most widely used. So relational databases, guys, allow us to make relationships between tables. And for how databases kind of evolved over time. So in 1960, we started off with something very remedial, and then over time it got more and more advanced. It went from flat files to hierarchical to network to relational databases in the mid 1980s, to object-oriented databases and object-relational databases in the 1990s, right? And then it just got a lot more advanced since then. All right, so the range of database applications, personal databases, all right, two-tier client server databases, multi-tier client server databases, and enterprise applications, enterprise resource planning, and data warehousing. All right. Now there are different approaches to developing databases. So one is the system development lifecycle and prototyping. Now, SDLC, the lifecycle that we have here, starts off with planning. So we plan the database first, then make analysis, then we design the database, right? So logical design and physical design, the implementation, implementing the database, and then maintaining it. So planning. So planning stage is purpose driven. So it's preliminary understanding, deliverable request for study, and database activity is the enterprise modeling and early. So we're kind of modeling the database and kind of seeing what it will be used for, pretty much. Right, analysts. So the purpose is thorough requirements analysis and structuring. So we're structuring the database and analyzing what needs to be in it. We're delivering a conceptual schema, so conceptualizing what actual objects need to be in the database, and thorough and integrated conceptual data modeling. Right. So now it says conceptual data modeling is defining a defined detailed inventory of data attributes, right? List of all data categories, establishes relations between data categories and results in conceptual schema as usually displayed graphically. So we are pretty much listing all the categories that we're using in our database and displaying them graphically. Now, logical design. This information requirements, can't say that word, elicitation and structure, detailed design specifications. So we're kind of talking about, what the database will look like what information will it have exactly, like will it have maybe, for example, student's name, address, what kind of information will be inside of it. So in the activity, transactions, forms, displays, views, data integrity, and security. Alright, so we are transforming the conceptual schema to logical schema, describe data in terms of data management, technology that will be used, right? Transform data to atomic elements through process of normalization, right? And then the physical design, develop technology and organization specifications, define database to DBMS, so to work with our management system, physical data organization, and database processing programs. So describe how data will be stored and managed by the technology. So how will we actually take this data that we have here and store it? Then responsible for specification for memory, management, storage layout, data indexing, etc. Results in a physical schema. Right? And then implementation. So how are we going to actually implement this database, actually use it, right, in our program? So we designed it, we designed the database, right, designed it, and created the schema for it, right? What it will have in it, what data will have in it, how it will look, and then we talked about how we'll implement it inside of our program. So how will be connected to our front-end program, right? And then maintenance. So maintenance is repairing it, fixing it, monitoring it, make sure that it's still working properly and there's no errors. So conceptual schema is a detailed technology-independent specification of the overall structure of organizational data. A logical schema is a representation of database for a particular data management technology, and a physical schema is specification for how data from a logical schema are stored in computer secondary memory by a DBMS. So there's different steps of creating a database, right? So conceptualizing it, then making it make sense, and then saying how the data will be stored. Right, so that all is before implementing the database. Okay, then maintenance, we are identifying any problems that we have in the database. Right, we are going to keep testing it and making sure that the problems do not occur in the next version of the database. Right, so here it says conceptual data modeling, identify the problem, then we develop initial prototype, logical database design, analyze requirements in detail, right? And then we will then create the database, so implement the prototype, okay, and then we'll revise it and make sure that it's working, and we'll maintain it. All right, so it's not giving us any errors. Right, so there's a whole step-by-step process, guys, in making a database, right? So we start off with first conceptualizing everything, and then bringing that to life, implementing it inside of a program, and then revising it and making it make sense to keep working and getting bigger as the database grows. Okay. So now it talks about System Development Lifecycle, SDLC, detailed, well-planned development process, time-consuming but comprehensive, long development cycle. Prototyping, rapid application development, RAD, cursory attempt at conceptual data modeling, define database during development of initial prototype, repeat implementation and maintenance activities with new prototype versions. So we are prototyping it to make sure that the database is constantly working, right? And we're maintaining that prototype and adding new versions to it. All right. Okay. So challenges: new specialized personnel, installation and management costs. So, guys, maintain a database as it grows is not free. You have to, pay for tiers, pay for space, pretty much, cloud storage, right? So, for example, Firebase, you can get a database, but if it grows very, very large, you might have to start paying for it, right? So they're not all free, right? Need to back up for recovery. If there's any problems, you have to recover your database, make sure it doesn't completely get wiped out or lost, right? There are conflicts in organization, so there are some challenges with using a database and managing it, right? So yeah, that is it for the slide. Okay, so for the next slide, we'll go into that one after. Lecture is this part, M1, basic SQL statement 1. Okay. So here we're going to talk about SQL. So we're going to learn basic projection, restriction, and rename expressions. Learn syntax for the basic SQL statements. Learn conditions and functions. Structured, so SQL stands for Structured Query Language. It's used to interact with tables and relational databases. So SQL, there's DML and DDL. Terms in SQL are DML and DDL. So the SQL select statement is a very important part of SQL, right? The SQL select statement is viewed as part of the DML family. However, select statement alone does not modify the data permanently in the database. Select is a read-only operation when applied alone without other DML or DDL operations. Relational algebra is used as a generic method to find logic of SQL statement before writing SQL. So we use the select statement, guys, to select and read elements inside of a database. All right, so select statement returns a relation. The basic select statement returns exactly the same number of columns and rows of its relation. The star symbol identifies that all columns are selected. So if we say use HR, go, select all, so we'll select all the data from the countries table. Right? Projection is an operator that allows selecting a subset of the relation columns. Projection is defined by stating the columns that are related to be selected. So use HR, go, select first name and last name from employees. So we're selecting these rows from this table, employees table. Rename operator allows renaming the attribute name in the output relation. So select first name, and we're going to rename this column as employee first name, and select last name as employee last name. We'll rename it to employee last name from employees. Selecting a set of rows based on a condition. Where clause is used to define a condition expression. So select street, address, and postal code communications, where city is equal to Toronto. So we're going to be selecting only the street address and postal code from the locations table, those columns where the city is Toronto. So restriction where allows us to restrict what we're selecting. So here we have a little activity, 10 minutes. It says select the below from employees table, employee first name, last name, phone number, and email for all employees, and the job titles that have maximum salary equals to 16,000. Rename your job title to high earning job. So I'll let you guys do that on your own. Just make 2 statements. Right? So that one will select the employee's first name, last name, phone number. Which isn't that hard. We see it here. Just like first name, last name, phone number. Just write it out on your own, okay? And then it says to take the job titles at maximum salary equal to 16,000. So you need to make a where clause where maximum salary is equal to 16,000. All right, and we rename the job titles to high earning jobs. So you guys can do that on your own. And functions that can be used together to develop a selection restriction. Condition is the term that describes how a column values compares to a value or set of values. So function is a term that modifies a column value to be used in the comparison. So here, guys, we are using comparison conditions inside of the where clause to check to see and compare the value to this column. So we're saying select all from jobs where max salary is greater, right? This is greater than 8,000. This one is greater or equal to 8,000. This one is greater than 8,000. Okay, and this one is not equal to 3,000 for minimum salary. So you guys can use a where clause with comparison conditions to check things inside them. So logical conditions, all right, with and or, and not. So with and, both have to be false for this to be false. Now both have to be true for this to be true. If we're using and, okay. If we're using or, all right, only one has to be true for it to be true. Okay, so or looks at one side, and looks at both sides. So here for and, if we have false and true, they're both not false and both not true, so it's false. This one, false and true, they're both not true, so it's false. True and true, they both are true, so they're true. For or false, they're both false, none of them are true, so it's false. False and true, true is there, so it's true. True and true is true, and true or false is true. Not truth, not will just negate what it is, so if it's false, it's true, and if it's true, it's false. So it says try the logical operators on the right screen of the slide and observe the results. So guys, we'll go over this next week anyways in class, don't worry. Try to write the statements in a different way to give the result, the same result. Okay, so this is try logical operators. So we have operators here. Okay, try to write the statements in a different way to give the same result. Okay, so you can try to write them in a different way. Each statement here. Okay, so you can say, instead of saying we're not true, you can say we're false. So you can just write it in a different way. I'll give you guys some time to work on that. Try the SQL statement to your right and discuss with your colleagues and teacher what the purpose of the like condition. Right, so we have where first name is like Herman. So let's look this up and double check this. So like condition SQL. So it says, the like operator is used in where clause to search for a specific pattern in a column. There are two wildcards often used in conjunction with like operator. The percent sign represents 0, 1, or multiple characters. Underscore sign represents one single character. So we're looking for format here with like. So for all the customers where customer name is like this, they'll return it. So we see here, all the customer names who have a character and one or more are multiple characters for the name. So more than one character for the name. So many people. Let's start with A first. They start with A and they have more than one character after. So these are all. Okay. If I did B, we get all the ones that have start with B. So guys, you can actually use W3 Schools to do SQL. I actually recommend that you try doing these examples using W3 Schools. Okay, so I'll post this on Discord for you guys to take a look at. Now the next one says, so for this one, we're looking at, it starts with Herman for first name, and it can be in these formats. So Herman, just the word, Herman with another extra character, Herman with two N's, Herma with the extra character at the end, and Herma with multiple characters. So pretty much all different ways of getting that word. Below are some other popular conditions between evaluate a range against value against a range, and in evaluates a value against a set of values coming from this. So use between and in conditions to write a statement that will get all of the information from countries table for Brazil and Belgium. So you can use between to get them from between Brazil and Belgium, right? And in, write a SQL statement that will get all the job titles that have maximum salaries more or equal to 6,000 and less than or equal to 16,000. Evaluate a value against a set of values from the list. Okay, so you could probably use maybe in for this one then, and between for this one. All right, let's look them up on W3 Schools. There's in here. So it says select all customers from country in Germany, France, and UK. So in this example here, yeah, so you could do in for countries, Brazil and Belgium, this one, right? And for this one, you could do between, which is here. So we're gonna do, yeah, a range of numbers. So this one we can do the next one with between. Okay. Now, last example here, we see null value means that there's no data for that attribute. Try the select statements to the right of the screen and discuss with your colleagues and the teacher your conclusions on the null value. So here we have from course if where name is null and where name is not null. So we know null means that doesn't exist, right? So if the name in the course is null or not null, we can get back, return something. Is not null and null. So we know null just means that it's not there, right? No value. So you can use null, and you can use null to get back tables that have no values or columns that have no values. Right? For this week is basic SQL statement 2. Okay. So objectives, learn how to use functions with SQL, learn the syntax of some of the most common built-in functions. What is function? So function syntax. Why do we need functions? Where can we use functions in SQL? So look at the SQL statements to the right, answer the below multiple choice question. Where can you use functions in SQL? Projection, after select, right, like this. Restriction, after where, like this. All of the above. So we can use functions, guys, to get to get different results. So here I can get select minimum salary that is rounded to -3. Function says function rounds the number to a specified number of decimal places. Right, so if I try this example here, I can see that it rounds it to 2 decimal places. If I do 1, it'll round it to 1 decimal place. Right? If I do 0, it takes off all decimal places. Right? So in this one, we have -3 in that example. I do -1. Right? So it just takes off, it deletes the decimal places based on position. If I do 3, everything should be 0. Exactly. So what this does here is it will delete the decimal places, right? Round decimal places. So here it says condition expression. Activity 45 minutes. So study the below functions and answer the questions in the next slide. You will find functions descriptions in the description below. Right? So you actually guys can just use W3 Schools and just search up each one of those functions there. Right? So concat, replace, round, ceiling. Just search SQL, concat. Right? W3 Schools has the definition. So concat will add 2 or more strings together. So add the strings together. All right. Replace. Okay. Replace will replace the T with the M here. The T's with M. So we can replace characters. What else? Floor will obviously round down, and ceiling will round up. Okay, date, name, let's look for that. So date name returns a specified part of the date, of a date. Right, so date name, here, year, return back just the first part of this date. Right, if I put here month, returns, oh, year, gets back the month, and then the day gets back the date, right? So you can guys just look up these on W3 Schools, right? And it says, just go through each one of them. Then what are the country names in the country table that start with either upper or lowercase b? Right, so you guys can use these functions to find it out, upper, lower. Just look it up here. And if you guys don't understand it, don't worry, we're gonna go over this again when I come back. Alright, so it will make everything uppercase. This will make everything lowercase. Alright, date part. Specified part of the date. So very similar to date name. Right? Date name. We looked at it already. Date name. So you actually can put in any of these to get back a part of the date. Date diff. The difference between two dates. You guys get the point. You can just use W3 Schools to find everything. So 6 days, 6 years is a difference. All right, if I put here 2023, it's going to be 12 years. All right. So just do a statement, guys, where the country names and country table that start with either upper or lowercase b. Show the commission underscore PCT column of all the employees and employees table, rounded to 1/10. Additionally, do not show the rows where commission does not exist. All right, so show all the employees who were hired in 2017. The date of employment is stored in date of employment column. This employee table is stored in section 7 database. All right, so now I think maybe this data, we can connect to it using Azure. So I'm gonna make another video going over that. We'll also go over that next week in class, in person. I'm gonna post a video how you can connect to the database the next video. I just wanna post the lecture first. All right, guys, this is the lecture for this week. All right, sorry I couldn't be there. Next week I'll be there and we'll go over everything again. But I'm also gonna make a video just talking how we can connect to the database. All right, thank you guys.